Hey class, so a few of you pointed out to me yesterday that problem number 6 on today's homework, where it talks about this heat loss with all these crazy values in it, was material that we didn't get to on Wednesday, and the reason we didn't get to it was because we were too busy having fun with the liquid nitrogen. So the liquid nitrogen just took a little longer than I had anticipated, and yeah, so thank you for pointing that out to me. So I want to talk a little bit about the concepts involved in this problem, and hopefully you'll have time to watch it before class and before homework's due. Anyway, so what we have going on here, as the problem tells us, we're out camping one night. We got a thick wool blanket, which you can think of as like the top of your sleeping bag. Sleeping bags are a little better at keeping the heat in than this is, but a thick wool blanket's not bad either. Anyway, and so we're asked to determine how much heat energy we lose out of our blanket or through our blanket. And so heat is a flow. It's usually has units, as we'll find out today, of joules per second. So it's really like a power quantification in a sense, or the same units as power. So the question is, how much heat are you losing? What's the power of that? So the equation that we're going to talk about in class a little bit today is that heat, we'll use H for heat. Okay, a lot of times you'll see Q used for heat as well, but I'm going to use H for this. So heat loss, or that moves, is equal to your temperature difference, so delta T, the change in temperature between the two sides of your object, K, which I know we're tired of seeing K over and over again, but K in this case is the thermal conductivity of your object. So thermal conductivities are experimentally determined based on the material. In this case, we're told what the thermal conductivity of wool is, 0.07 watts per meter times Kelvin. And then you multiply that by the area of your object, and you divide all of that by D, which is the thickness of your object. Okay, so the question then is, in this case, what is our heat loss? Well, our heat loss is going to be equal to the temperature difference. So we usually would want to use Kelvin, but with temperature difference, Celsius and Kelvin are going to be the same. So the difference between the -5°C outside, it's a chilly night to be camping. It's like camping in Colorado. It always gets super cold at night, even in August. Anyway, -5°C outside, 20°C is what you wanted in your blanket to be nice and warm. And so your temperature difference would be 25°C, or that's the same as 25 Kelvin in temperature difference. Our thermal conductivity is given to us 0.07 watts per meter times Kelvin. And then the area is the size of our blanket, which would be 1 times 2 meters squared is what our units will come out there. And then you divide that by the thickness of your blanket. Again, we want meters as our units, and so this would be 0.015 meters. Alright, so there's that, and you guys can do the calculation. You should be able to come up with a correct number, and what you'll find is the number is the equivalent of like 4 light bulbs all burning at the same time, which is pretty wild amount of heat you're losing all the time. And then the next question asks us what the total energy is. So the energy is equal to power times time, and so the energy that you're going to burn during the 8-hour night will just be equal to your power, your heat from up above, this number that you got here, multiplied by time, and the units of watts, which you'll get from the heat, so your number is in watts. That unit is joules per second. So when you multiply it by your time here, T, you need to make sure that you use seconds. So 8 hours converted into seconds, and you'll find it's a pretty surprising number of joules that you lose during the night. And keep in mind, as you look to answer the question C, everything that we've quantified here, this large number of energy that we're losing here, is the energy just being lost through the blanket. Alright, so all this quantification is about the energy being lost for the blanket. So as you consider part C, keep that in mind.